Good afternoon, everyone. Welcome to Data Mining and Emerging Technology session, and thanks for your interest in my presentation. I'm Ali Kamali Mohamadzadeh, a PhD student at Industrial and Systems Engineering Department at Wayne State University, and my presentation is titled Collaborative Human-Robot Interaction, a Virtual Reality-Driven Approach. In my presentation, I start with introducing some main concepts and definition. Then I talk about motivation and objective of the study. Then I will review the literature of the subject. And then I will talk about the methodology. I'll talk about results and discussion afterwards. And finally, I will discuss future works. I'd like to start with a very brief review of industrial revolutions and their characteristics. The first industrial revolution was the transition to new manufacturing processes using water and steam. During the second industrial revolution, new technological systems such as electrical technology were introduced, which allowed for greater production and more sophisticated machines. The third industrial revolution involved the use of electronics and IT and introduced more automated systems such as PLC in order to perform human tasks. The fourth industrial revolution was about systems that autonomously perform actions and exchange information without human intervention. And finally, Industry 5.0 is the era in which human and machine work together to improve both effectiveness and efficiency of production. This is the era our research is focused on. Another main concept of this research is human-robot interaction, or HRI, which is defined as a field of study dedicated to understanding, designing, and evaluating robotic systems for use by or with humans. HRI interaction can be separated into two general categories: remote interaction, in which the human and the robot are separated, such as Mars rover or search and rescue robots, and proximate interaction, which is what we will focus on and is about the scenarios in which humans and the robots are co-located, such as service robots, which are in the same room as humans. HRI can be used in different domains as well. Healthcare, manufacturing, and entertainment are just three examples of different domains where HRI can be applied. And regarding the level of autonomy, HRI can be divided into 5 categories, ranging from teleportation on one end to peer-to-peer control on the other end. Our research lies in collaborative control. The next topic is immersive technology and extended reality, or XR. Immersive technology is the technology that blurs the distinction between physical and virtual worlds and enables user to experience a sense of immersion by that merging physical and digital reality. Two important terms in immersive technology are immersion and presence. Immersion refers to the objective level of fidelity that an XR system can provide, while presence refers to a user's subjective response to an XR system. So immersion is objective and measurable, while presence is an individual response. Next terms are VR, AR, and MR, virtual reality, augmented reality, and mixed reality. VR refers to a completely digital environment. AR, on the other hand, refers to real world augmented with digital information. And finally, mixed reality, MR, is about where real world and virtual world are intertwined. Now, nowadays, in the domain of manufacturing, XR proved to be very effective and a game changer, and it demonstrated significant advantages such as turning processes more efficient, enhancing worker productivity, improving plant utilization, and contributing to design and improvement. Regarding the applications of XR in manufacturing, a survey revealed that applications such as product design and development, safety and manufacturing, skills training, and maintenance, repair, or operation of equipment are the most popular XR applications among manufacturers. You can see other applications as well. This survey had 120 respondents, and this question was one of the questions where respondents could choose multiple answers. Now let's talk about the motivation and objective of this study. On the upper left in figure 4, you can see manufacturing labor productivity from 1987 to 2018 and the labor productivity forecast up to 2030. As you can see in the past decade, which can be considered as Industry 4.0 era, labor productivity has been stagnant for almost a decade. And also during this time, we witnessed 75 million traditional job decline. On the upper right, in figure 5 demonstrates the paradigm shift toward mass customization, in which innovative manufacturing methods are to be applied in order to create competitive advantage. So these two figures together demonstrate the challenges which HRI can help overcome. For instance, HRI allows robots to take care of repetitive tasks, while humans can take care of innovative part of manufacturing. So having said that, our goal in this research is to develop an intelligent, proactive human-robot interaction framework, and we are using a VR-driven approach to do so. The next topic is literature review. To recap what was discussed on HRI, human-robot collaboration is a new frontier for robotics, and human-robot synergy can constitute a relevant factor in industry for improving production lines in terms of performance and flexibility. As you can see, our literature review shows that the research on HRI is very diverse and contains various types of robots, control systems, collaboration methods, and applications. For instance, control systems can be gesture recognition, vision and audio recognition, admittance, vision, sensitive skin, etc. And application can be assembly, human assistant, quality control, etc. In this research, our control system is a combination of gesture recognition and human tracking, and our application is human assistance. Here, these four figures show how interest in HRI research is increasing. On the upper left, figure 6 shows usage of robots in HRI, where you can see interest in both industrial and cobots are increasing during the past few years. Figure 7 shows the tasks assigned to robots in HRI. Again, the increasing trend is obvious. Figure 8 shows the objective in HRI, which are three classes: productivity, safety, and HRI. Again, you can see the increasing trend. And finally, figure 9 shows the control system used in HRI. So in all the figures, increase of interest in HRI can be obviously seen. Next, I'm going to talk about our methodology. Our methodology can be divided into 4 phases. The first phase is creating the immersive platform. So first we develop an interactive physics-based model using Unity game engine, and then we integrate that model with HTC Vive Chroma Scale technology. By combining both these stages, we will create our immersive platform that allows us to move to phase two, which is data collection. In the data collection phase, our collaborators from School of Dance at Wayne State University employ a methodical approach to collect the data using an improvisational framework using parameters of time, space, and personal range of motion. This framework allows us to explore a very wide range of movements and movement possibilities, and we will be able to produce a rich range of data within a single task. And then we proceed to phase three, which is the prediction phase. As you can see, we have two different prediction models, one trajectory prediction and one intention classification, which I will discuss in more detail in the next two slides. After building these two models, prediction and classification model, we will combine the two and create an ensemble deep ANN artificial neural network model, which will be our final prediction classification model. After this phase, we proceed to the final stage, phase four, which is integration and validation. We will integrate the whole framework and use the immersive platform that we built in the first phase to validate and implement this approach. This slide is about the first classification, the human intention classification model that we are building. And the literature on the subject shows that HRI can largely benefit from understanding human intention. And also it shows us that human behaviors and motions are very rich in intention information. Regarding the research that have been done and the methods that have been applied, as you can see, the methods are diverse, and before 10 years ago, many different methods were used, such as human Markov models and many more methods. But in the past few years, past 5-6 years, usually researchers tend to use neural networks and deep learning methods much more, and we have seen an increase of interest in such methods. Among them, you can see artificial neural networks, recurrent neural networks, specifically long short-term memory networks, and also CNN networks, convolutional neural networks. The second model was the human motion or human trajectory prediction. For this task, the literature review shows that, again, in the past few years, neural networks were very popular, and in particular, recurrent neural networks were used so often. The reason is due to the temporal nature of this problem, and recurrent neural networks are very powerful in capturing these temporal relations. Among the recurrent neural networks, in particular, long short-term memory, or LSTM, has been very popular, and the reason is that LSTM is basically an improvement over original recurrent neural network, since it creates both a short-term and a long-term memory component, which allows for better tracing of temporal patterns. In the results and discussions, I should mention that due to some disruptions that we've been having, such as the closure of research labs or due to the COVID-19 situation, we've had some difficulties regarding data collection. And currently, at this time, we don't have a statistically significant amount of data for creating and hypertuning our prediction models. So at this time, we have completing integrating the developed virtual model using Unity and HTC Vive room scaling technology, as well as the literature review on machine learning and deep learning models in HRI. You can see in the right side a picture of a part of the Unity model we've built, and you can see the robotic arm inside the model. And on the left side, you can see me that I'm using the HTC Vive in order to have an immersive experience in the created model. Regarding our ongoing and future work, the next step would be the completion of data collection and data gathering. After that, we will train the two aforementioned models, intention classification and trajectory prediction models. After that, we move forward to integration and validation of the developed methodology. And then we will extend the whole framework that was discussed to multi-agent settings. So the current scenario is a single agent setting, and we will extend the current framework to multi-agent setting, which allows multiple humans to collaborate with the robot. And finally, we will include safety issues and challenges, both physical and psychological aspects to our research to also address this issue. So thank you very much for your attention. And that was the end of my presentation.